So today we're going to look at how to balance a special type of equation, a special type of reaction called a combustion reaction. You might recognize combustion. It's basically when something burns. And more scientifically, a combustion reaction is the reaction of a hydrocarbon with oxygen gas to form or to produce carbon dioxide and water. So a hydrocarbon means just a compound containing carbon and hydrogen. O2 is the oxygen, and so the products are CO2 and H2O. You'll know you have a combustion reaction if you have some sort of CH compound reacting with O2 to form CO2 plus H2O. Now, the key for these types of problems is to always balance in one specific order. If you don't do this, you will get confused as you balance. So first balance the carbon, then balance the hydrogen, and only then balance the oxygen. CHO, that's the order that you're going. So let's look at an example here. Now, I'm going to go start by doing the drawing method, then I'll go through using the math method. So if I'm using the drawing method, I'm going to go ahead and draw my particles. So CH4 stuck together in one particle, two O's stuck together, COO stuck together, and then two H's and an O. So I've got one carbon, four hydrogens, and two oxygens on the reactant side, one carbon, two hydrogens, and three oxygens. Notice I have to count the oxygens in both CO2 and H2O on the product side. That's what makes these problems harder, is that I have oxygen in two places. So carbon is already balanced. I don't have to do anything there. Hydrogen is not. I'm going to draw another water particle to make my hydrogens balanced. So now I've got my oxygens. So now that I've drawn another water particle, I have another oxygen. So I now have four oxygens instead of three. So I'm going to draw another oxygen particle on the reactant side, and now I'm good. So I have two H2Os, one CO2, two O2s, and one CH4. Let's do the same exact reaction, but let's do it the math way. So again, starting with carbon, then hydrogen, then oxygen. So counting my atoms first, one carbon on both sides, four hydrogens on the reactants, two on the products, two oxygen on the reactants, and three on the products. Again, make sure you're counting the oxygens from both particles, CO2 and H2O. So I'm going to balance hydrogen by multiplying H2O by 2. I'm not going to change the oxygen yet. Do not just multiply the O by 2. I'm going to recount by noticing that I now have two oxygens from H2O. I'm going to add because I've got the hydrogens in two different particles. I'm going to multiply oxygen by 2 on the reactant side, and then I am done. Let's look at a slightly more in-depth problem. I'm going to stop doing the drawing method after this practice problem because I do find combustion reactions can get really big, like the carbon compounds can get big, and I find drawing a little bit tedious for that, but you're welcome to continue doing so. So carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. Remember, that's the order we're always going to balance in. C3H8, I'm going to draw 3 carbons and 8 hydrogens, all kind of stuck together in one particle. I'm going to draw O2, and I'm going to draw CO2 and H2O. Now I'm going to balance my carbons first. So I have 3 carbons on my reactant side and only 1 on my product side. So carbon is my first point of attack here. So I'm going to start by thinking like, okay, if I need more carbons on the product side, I need to draw more CO2 particles. So I'm going to draw 2 more CO2 particles to get to 3 carbons. Notice I've also changed the number of oxygens by doing that. So I now have 3 carbons, and I now have 1, 2, 3, 4, 5, 6, 7 oxygens, because remember I have to also count the oxygen from H2O. So carbon is balanced. Now let's go to hydrogen. So I need many more hydrogens. I need 6 more hydrogens on my product side because I have 8 on the reactant side and only 2 on the product side. So I'm going to just keep drawing H2O particles until I end up with 8 hydrogens. Now I'm going to recount my oxygens again. So I've got 6 plus 4, that gives me 10, right? So over on my reactant side, I need to keep drawing O2 particles until I get to 10 oxygens. So that ends up being 5 O2 particles for 10 oxygens. Now let me just count and make sure, figure out what my coefficients need to be. So I've got 1 C3H8, 5 O2 particles, 3 CO2 particles, and 4 H2O particles. Let's do a slightly more difficult problem, and let's do it the math way. This is more difficult just because particles are getting bigger. It's not actually really that much more difficult. So carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. Let's do my counts. C5H12 plus O2 reacts to form CO2 plus H2O. Got 5 carbons, 12 hydrogens, 2 oxygens on the reactant side, 1 carbon, 2 hydrogens, 3 oxygens on the product side, 2 from CO2, 1 oxygen from H2O. Again, really be careful that you're counting both those sources here. Now, my carbons, if I'm going to balance them first, I need to multiply the carbon on the product side times 5. 1 times 5 is 5. I'm going to put a 5 in front of CO2. So by putting a 5 in front of CO2, I'm also changing the number of oxygens. So now I've got 5 CO2 particles, that's 10 oxygens there, plus the 1 from H2O. So now I've got 11 oxygens. Notice I cannot just multiply O by 5, right? I cannot do that in this particular type of problem because the oxygen is found in 2 different molecules. So to make hydrogen, to make 2 equal 12, multiply by 6. So I'm going to put a 6 in front of H2O. Now I'm going to recount my oxygens again. So I still have 10 oxygens from the 5 CO2. I'm going to have 6 oxygens from the 6 H2O. 10 plus 6 is 16 oxygens. Again, I have to make sure that I'm being careful with oxygens in these problems. So now I've got 16 oxygens on my product side and only 2 on the reactant side. So 2 times 8 gives me 16. And now I'm done. That's all I had to do. So 1 C5H12 plus 8 O2 reacts to form 5 CO2 plus 6 H2O is my balanced equation for this reaction. I'm going to leave us on a third combustion equation that is going to be a little bit more difficult. So this particular combustion reaction, you guys will see why this ends up a little bit more difficult. So let's do C4H10 plus O2 reacts to form CO2 plus H2O. Again, setting up my CHO, making sure I'm going in that particular order, carbon, then hydrogen, then oxygen. Now, I'm going to have a pencil ready because I'm going to be wanting to do part of this in pencil. So on the reactant side, I have 4 carbons, 10 hydrogens, 2 oxygens. On the product side, I've got 1 carbon, 2 hydrogens, 3 oxygens. 2 from the CO2, 1 from the H2O. Starting by balancing the carbon, multiplying 1 times 4 gives me 4. Again, I'm using a pencil for my coefficients here. I'm going to recount my oxygens. I now have 8 oxygens from 4 CO2 plus 1 from H2O. That gives me 9. Next thing I need to balance is hydrogen. Now this is where I'm going to run into a problem. I need to multiply 2 by 5 to make it equal 10, right? But if I put an odd number in front of 5H2O, that's going to mean that I have 5 oxygens from H2O. And that's going to mean that I'm going to end up with an odd number of oxygens, right? Because 8 plus 5, 8 plus an odd number is 13. Here's why this is a problem, right? I can't multiply 2 by a whole number to get 13. A couple ways to solve this. I could multiply by a fraction, but then you have a fraction as a coefficient and it's kind of funky. What I can do instead, if I don't want to deal with using a fraction, to switch erasers there, pain is real, guys, is I can double the coefficients that I have so far. Stay with me here, right? So instead of 4 and 5, I'm going to go 8 and 10, doubling everything. So now I need to go through and change the amounts of all my atoms here since I doubled it. You'll notice, right, when you double 13, 8 CO2 is going to be 16 oxygens, 10 H2O is going to be 10, 26. When I double 13, I get 26. That's an even number. So by doubling my coefficients, I get an even number of oxygens. This method always works if you're going to end up with an odd number of oxygens. So now, to make 2 equal 26, I need to multiply oxygen by 13. Now I need to go back and make sure my carbon and my hydrogens are balanced on the reactant side. So to get 4 to 8 and 10 to 20, multiply by 2. 4 times 2 equals 8, 10 times 2 equals 20. So I need to go put a 2 in front of C4H10. So that's how this type of problem can resolve itself, right? If you're going to end up with an odd number of oxygens on your product side, double everything. Now, I'm going to rephrase this in like a rule that you can kind of write down and think about. So in a combustion reaction, if you are going to end up putting an odd number coefficient in front of H2O on the product side, that means you're going to end up with an odd number of oxygens if you're putting an odd number there. You need to double the coefficients, double everything in the reaction. Those are the most difficult combustion reaction problems. The ones where you have to end up doubling them, because you can get really stuck if you don't see that at first.